Hello everyone. In this video we are going to discuss a problem on optimal generation scheduling including transmission losses while considering the B coefficients. Here in this problem we can see a two bus system is shown in figure here. If 75 megawatt of power is imported to bus 1, a loss of 5 megawatt is incurred. We need to find the required generation of each plant like PG1 and PG2 and the power received by the load, that's PD, when the plant incremental cost is 20 rupees per megawatt hour, that's lambda, and the incremental fuel cost of two plants are given by df1 by dpg1 is equal to 0.3 pg1 plus 15 and df2 by dpg2 is equal to 0.05 pg2 plus 18. Let's start solving with listing out the given parameters like first one is lambda, that's 20 rupees per megawatt hour, and we need to start by looking at the figure of the two bus system. We can see the load is specifically at bus 1, and with load at bus 1, P1 or PG1 will not have any effect on the losses incurred because the load is near to the generation, and the loss whichever occurring is only because of the generator 2, that's PG2. Hence we can come up with the idea that B11, the B coefficient, is equal to 0 and B12, which is equal to B21, will be equal to 0. Therefore PL is equal to B22 into PG2 square, and in this case you can see from the problem when 75 megawatt of power is imported, which means from generator 2 or bus 2, we can mark it as PG2 is equal to 75 megawatt, which leads to a loss of 5 megawatt, which means PL is equal to 5 megawatt. On substituting these two parameters or the PL, here we are having PL is equal to B22 into PG2 square, which can be stated as 5 is equal to B22 into 75 square, which leads to the value of B22 as 0.0008, which is a constant value and which is not varying. Now with the value of B22 as 0.0008, we can start the solution with the optimal real power dispatch. The optimal real power dispatch for plant 2 is taken as df2 by dpg2 minus lambda times 1 minus dou pl by dou pg2 will be equal to 0, or we can equate as df2 by dpg2 as lambda into 1 minus dou pl by dou pg2. But from the B coefficient or the loss equation, we are having PL is equal to B22 into PG2 square. With this equation, PL is equal to B22 into Pg2 square. If we differentiate PL, EPL, dPg2 leads to Pg2 square. If we differentiate 2 times B22, B22 is a constant, Pg2. Now the value of dou PL by dou Pg2 as 2 times B22 into Pg2, and dF2 by dPg2 we are having that formula, dF2 by dPg2 as 0.05 Pg2 plus 18. On substituting 0.05 Pg2 plus 18 is equal to, the value of lambda was 20, and 1 minus dPL by dPg2 is 2 times B22 into Pg2. Now the unknown value is Pg2. Previously, while calculating for PL, we assumed Pg2 as 75 megawatt. Now we need to find the actual value of Pg2. That's why we keep Pg2 as an unknown value, and we are going to solve for this. And now the value of B22 is, as calculated, 0.0008. On substituting, we get the value of Pg2, right? 0.05 Pg2 is equal to, if we take 18 this side, minus 18, 20 times 1 is plus 20, minus 22, so 40 times 0.0008 Pg2, 0.05 Pg2 is equal to minus 18 plus 20 is 2, minus 40 times 0.0008 leads to 0.032 Pg2. On solving, if we take Pg2 on the LHS, 0.05 Pg2 plus 0.032 Pg2 is equal to 2, therefore 0.082 Pg2 is equal to 2. On solving, we get Pg2 as 24.39 megawatt. This is the value of Pg2. Now with the value of Pg2, let us solve for plant 1, that it's a Pg1. For plant 1, dF1 by dPg1 is equal to, same as previous, lambda times 1 minus dou PL by dou Pg1. Since plant 1, as we started with the problem, plant 1 is generation is not affecting on the loss, we can say dPL by dPg1 is equal to 0, which means dF1 by dPg1 will be equal to lambda times 1 is lambda, and the value of dF1 by dPg1, as in the problem we have marked, dF1 by dPg1 is 0.3 Pg1 plus 15, with 0.3 Pg1 plus 15 is equal to, the value of lambda is 20. Now 0.3 Pg1 is equal to 20 minus 15, 0.3 Pg1 is equal to 5, and Pg1 is equal to 5 divided by 0.3. That's what Pg1 is equal to 16.66 megawatt. Now we got the value of Pg1 as 16.66 megawatt, and Pg2 here we calculated it as 24.39 megawatt. As in the question, they asked for find the required generation for each plant, and that's Pg1 and Pg2. Now we have calculated, and we need to find the power required or the power received by the load, that's PD. To calculate PD, the formula for PD is PD is equal to generation minus losses, and PD is generation is PG1 plus PG2 and losses is PL. And we started the problem with PL as 5 megawatt. That 5 megawatt is occurred when 75 megawatt of power is received or received from PG2 or bus 2 to the load. Now the actual value of PG2 is 24.39 megawatt. Here we can see it's not 75 megawatt. Now we need to calculate the loss due to this power received. Okay, the loss equation PL is equal to, we know that the formula PL is equal to B22 into Pg2 square, and now the PL is unknown, P2 to the constant value is 0.0008, and the value of Pg2 as calculated, here we are having 24.39 megawatt. Let us substitute that value, 24.39 megawatt square. If we solve this, we get the value of PL as 0.47 megawatt. This is the loss occurred when a power of 24.39 megawatt here is received from bus 2. This was our generation PG1, bus 1, bus 2, and generator 2, PG2, and here is our load. And PG2 is 24.39 megawatt. The loss PL occurred in this space is 0.47 megawatt. Previously it was 5 megawatt when 75 megawatt was received. Now with PL value and PG1 is equal to 16.66 megawatt as calculated, and Pg2 is equal to 24.39 megawatt as calculated. Now we need to find the value of PD. The value of PD is Pg1 plus Pg2 minus PL. That's our 16.66 plus 24.39 minus 0.47. PD, the actual demand is 40.58 megawatt, and these are the values that we need to identify from our question. And here is our question, like find the required generation that we have calculated, PG1 and PG2, and the power received by the load. That's our PD is 40.58 megawatt. Hope you people enjoyed and understand what the concept is. If you have any doubts, please do message or put a message in the comment box. We'll connect. Thank you.